Hello, hello. How's everybody doing today? Uh-oh, did I get a thumbs down again from Jessica? I got a thumbs up from McKenna. So what's wrong, Jessica? Same old stuff? Ugh, work. Yeah, this is my work, so sorry. Thought you'd think that was funny. Okay, let's see. Did I get everybody who's here? Michaela, Bethel. I feel like I'm missing someone. 1, 2, it's Elena. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8. Obviously, I've missed someone. Brianna and Sydney. Essay. All right. Okay, well, it's our last T-shirt Tuesday. I know. Are you crying inside? Who's crying? Yeah. Thanks, Tyler. I appreciate that. All right. I know Jessica has a shirt to share, right? I know Tyler always has a shirt to share. I have a shirt to share. Since you just heard it was our last T-shirt Tuesday, if you need to run and get a T-shirt, you can. It's okay. I will let you. I will give you that minute. All right. So who wants to share first? Jessica, are you ready?
Sure. So I don't know if any of you guys heard of the Phoenix Rising soccer team. So I went to their game Saturday night with my brother, and one of the players accidentally kicked the ball right to my ear when trying to clear it from a player. So he felt super bad and gave me his jersey. Ryan Flood, the newest player.
Nice. Yeah, he should be feeling bad. Nice. Well, and you were not too hurt?
No, it was just directly at my ear. It hurt, but luckily it didn't hit my head, so I didn't have any concussion or anything.
How close
if I turned,
were you?
I would have gotten it straight in the face, but
how far away were you when he kicked it?
Our seats were by the other players' benches. So say we're right here, he was right here. He tried to cross the ball away from the player, but it went diagonally to my ear because I was for some reason faced away to eat some food or something.
Okay, give me some measurements. Give me some measurements. I need feet, right?
If I had to estimate, probably 6 feet. 6 to 10 feet.
Okay, 6 feet is really close, just so you know.
Yeah, I know.
Okay, because I'm were you that close? Because
we were pretty close to the field, yeah.
Because that could have been a concussion right there, right? Crazy. Okay. I don't see Sunita yet. How about Andrea? Just
I'm
making
here.
sure I have everybody. Okay, good. Who said I'm here? I feel like it was Sunita.
Yeah.
Where? Oh, there you are. I'm where are you? I don't even know why I couldn't see you. Sorry. I was looking at the bottom of my screen. Why? I don't know. Maybe I thought it was in alphabetical order today of all days when it never is. Okay. Yeah. Okay. Tyler, I'm ready. Great story, Jessica. Great shirt.
Yeah, I don't know if mine can actually top Jessica's because when I got the shirt, I wasn't in physical peril of any means. So this is one of my favorite shirts. It's just a black shirt that says "You are beautiful" on it. It looks probably backwards in the camera.
Nope.
On the back. Okay, cool. On my end, it does. So I was like, oh shoot. On the back, it has all the bands that were attending Life is Beautiful 2019, and artists and everything like that. I was able to go there for, I think it was like 8 days. I got all access VIP to the whole concert and festival, everything, everywhere, because I was working for Dutch Bros. It was like their first event. So this is like my favorite shirt in the world because I got to go to Vegas paid and just have a killer time.
Okay, now you have to show us the back. Sorry. Nice. I believe it was 2018 because that's what your shirt says, just so you know.
Yeah, I just realized it said 2018. I was wrong.
I was going to say time flies, right?
Yeah.
Okay, that sounds awesome, Tyler. Okay, anyone else have a shirt to share? Nobody has a shirt to share? Well, at least the two that we got shared were good. Mine is an oldie but a goodie. I felt like it was like party time with us. And since we're getting into formulas soon, we're going to do this shirt again. I know I need more shirts. It's okay. Maybe I'll get a side job at Dutch Bros and get some more shirts. I'd be a terrible Dutch Bros employee, let me tell you. It would not go well.
You say it like I'm the best one. I mean, I'm not that great either.
I bet you're great. Way better than me. I don't even understand Dutch Bros, so let's just start there. I've never been to Dutch Bros. Can you believe that? I think I drove there one day because my kids wanted me to go there, and then they were like, line's too long, we're not waiting. And then it was over. So never done it. Yeah. Well, I don't drink coffee, right? And I know there's a lot of sugar in some of their drinks, so I don't do that. And I'm a horrible cheapskate. So let's just start there, right? If it's more than $1, I'm pretty sure I'm not going to buy it, right? I just go to Salad and Go and get their $1 drinks. Yeah, it's true. I know people love Dutch Bros. My kids like Dutch Bros. They just never go because I'm a cheapskate. So there you go. All right, so here's my shirt, oldie but a goodie. Come to the nerd side. We have pie. I think some of you are almost at the nerd side, if not already there. You've crossed over. You're like, okay, it's true. I like math more than I thought I liked math. Yeah, it's true. Some of you are like, I already liked math, and this just solidified that math is amazing. Yeah, I feel that. Okay, so today, oh, let's see what my slides say. It's like an adventure because I've been doing way too much. You can tell by my grading, right? And everything that I've been doing a lot. I'm doing good. I think all I have left, well, I mean, until you turn in another assignment, right? Is oink. I have oink left. Yeah. I have that discussion board left, which takes me a while to grade those. Okay. All right. So let's make sure I get in the right class. Don't know which one it is. Think it's this one. This looks like it. All right, so surface area and volume. Wow, I didn't do any warm up or anything. So yesterday we were talking about nets. Some of you did cubes or not. Some of you started on that activity like we all did the part of it in class, but then some of you did the electronic version. Did anyone try the electronic version and like it better? Yeah. Okay, look at all those hands. Yeah, it was kind of fun. I think it's a fun one. Did you try to play it more than once so you could beat your time? Yeah, Tyler. See, I'm on the same page as Tyler. I would have kept playing it. Sunita's like, no, I just had to be done. It was checked off the list. Move on. Yeah. Yeah. Okay. So in order to do surface area, we have to know those three-dimensional shapes, right? And if you noticed on Canvas, I'm almost positive I put it there. I should check. Did I put a Quizlet on the polyhedra? So you could quiz yourselves on the polyhedra. Did you guys see that? It's there just in case you need it. So it's just a little Quizlet with flashcards to help you. So in area formulas for the final exam, you should know the formulas. I'll just write them here. I think it's on my review sheet. I'm positive it's on my review sheet. No, for final. So the area of circle, parallelogram, triangle, trapezoid, square, but I don't need to write that because it's also a rectangle. I think that's good. You also need to know circumference. I don't think I asked you perimeter, but you should know perimeter of anything. It's just the distance around the outside. Euler's theorem, interior angles. I'm trying to think if there's any other ones. That's all I can think of right now. I was just previewing your final yesterday. Since it's open now, right? I wanted to make sure I didn't have any typos in it. I probably still do. I looked as much as I could. You will be given a formula sheet for volume and surface area, okay? But I don't want you to worry about that yet because we're going to talk about discovering things. But when you don't need to memorize those formulas. These formulas you should have memorized, okay? All the ones I've listed here. So any questions before we start with surface area? By the way, one of the things I'll show you, and when we do volume 2, is I have this. These are called relational geosolids. And then I have a giant version of them. Yeah, giant geosolids. These are great manipulatives to have when you do surface area and volume, because it's helpful for us to understand what things look like this one right here. I don't know if you can see this. Can you name this shape? You can just say it out loud or type in the chat. What is this?
A rectangular prism?
Yeah, it is a rectangular prism. So when you buy these geosolids, they label a base with a different color. So you can see that that one's green and all the other faces are yellow. And I know it's probably kind of hard to see on here, but they also have little holes in the bottom of them. You can take off this little lid because they're fillable. Okay, so you can fill them. So these are the tiny versions. So that's a rectangular prism. This, oh, see if I can get it out of the box. This one, can you see this one? What's this one?
That's a pyramid.
Yeah, and it's a square pyramid. Like I could tell it's a square. If you were unsure, you could call it a rectangular pyramid, but it's a square pyramid. It comes with a cube. You know, it comes with a cone. It comes with a cylinder. It comes with, I don't know where this bottom went. Oh, there it is. Somehow this got, oh, that might be broken. Interesting. This one, it's a little triangular prism, a small one. And then there's a tetrahedron. There's a hexagonal prism. Kind of nice. You have that. So these shapes are great to have in your classroom for all kinds of activities, hands-on activities. And these big ones are excellent. So surface area. Surface area is the sum of the lateral faces, all the areas of the lateral faces. So what's interesting is surface area has the word area in it, so they must be very similar, but now it's of a three-dimensional shape. So we're trying to cover the three-dimensional shape. The easiest thing to compare it to for students is wrapping a gift. Yeah, if you wrap a present, that is surface area because it's how much wrapping paper do you need to cover it. Now, if you're me, you cut off way too much wrapping paper or way too little wrapping paper, right? Yeah. So, but, and of course, surface area is measuring it perfectly, right? No overlap, no gaps or anything. So, other examples of when you would need surface area. Painting a house. Has anyone painted a room recently? Yeah. So if you're just painting one wall, that's just, the area of one wall. But if you're painting a whole room, you might need to calculate the surface area so you know how much paint you need to buy. And they have those paint calculators on websites now, right? To help you. Okay. Cardboard box templates. Oh, anyone, I worked for a pizza place. I don't know how many pizza boxes I've folded in my lifetime, more than I ever wanted to. Okay. So just remember, what's the difference between a prism and a cylinder? This is a prism. Okay. And how many vertices, faces, and edges are in this triangular prism? Think about it. Look at the picture. Get it ready in the chat. Everybody have an answer to that? All right, let's get ready in the chat in 3, 2, 1, go. Do we all agree? Nice. Okay, and it's a triangular prism because the bases are these triangles here, this one and this one. So if I asked you to find the surface area of this prism, what would you do? How would you do it? Any ideas? Give me something, guys. Area times 2, says Jessica, but with a question mark, uncertain. Amanda says find the area of each face. And then what do you do with it, Amanda? Then you add them up. Anyone else have an idea or agree with either Jessica or Amanda? Betty's saying area of the triangle times 2, then the area of the rectangle times 3. I think. I like that. Which is kind of what Amanda's saying, right? Find the area of each face and add them up. Jessica, what do you think about that area times 2? What were you thinking of
I was kind
timesing
of thinking
2?
the same thing, but I forgot to realize of the rectangles. I just immediately looked at the faces and I was like, okay, area of the triangle times 2, but since they're rectangles, you need that in there.
Yeah, which is true. I like that you had the area of the triangle times 2 because there are 2 of them. Good. Okay, so I'm seeing a lot of I agree in there. All right. So, yeah, you totally can do that. Find the area of the triangles, then find the area of each of the faces. Now, what Betty was saying, can I just find the area of one of the faces and multiply it by 3? You totally can if what is true? What would have to be true for you to just be able to find the area of one of these rectangles and multiply it by 3? Anyone know? Yeah, if all of them are the same length, right? Like the triangle. So if it's, what type of triangle would it have to be for that to be true?
Equilateral.
Very nice. It has to be an equilateral triangle. Now, I usually have my boxes sitting here and I don't see them. That's depressing. Usually I bring a whole bunch of boxes to class on this day. And I don't, I must have been cleaning and thinking, oh, those are messy. I should not keep those here. How many have ever heard of candy called Toblerone? Yeah. Okay. So this right here, it looks just like a Toblerone box. Yeah. So let me look one more place. Maybe I have a secret Toblerone box. No, apparently I need to buy more. That's what happens. So a Toblerone box looks just like that, and it's chocolate candy. It's very good. This is another one of my favorite boxes. So has anyone ever had these Stroop waffles? Yeah, anyone ever seen these Stroop waffles? Okay, now look at this box. Here's the bottom of it. What shape is it? What is that?
A hexagon.
Yeah, that's a hexagon. And the top is a hexagon too, by the way. It's very fancy folded. But so what is this called? What is this shape called? A hexagonal prism. Absolutely correct. Now, could I use the same strategy on this hexagonal prism that you guys just came up with for that triangular prism? Could I find the area of this bottom, multiply it by 2, and then find the area of all these rectangles? Yeah, and then add them all up. Yeah, and what's nice is this is like a perfect hexagon. What do we call that when they're like perfect, all equal angular and equilateral? Regular. Thanks, Michaela. Look at that vocab we're practicing. Yeah. So I could find the area of this. Now, how do I find the area of a hexagon? We don't know that, do we? It's not one of our formulas. Anyone have a strategy on how they could find the area?
Since we know there's 2 trapezoids, we could just do the area of trapezoid times 2.
I see. You guys are amazing. If you wanted to, you could break it up into 6 equilateral triangles, but that seems like a pain, right? I like the 2 trapezoid idea. So see, you guys know more than you realize. These are great activities for kids in class. When we're in class, I usually give you a shape and have you calculate the surface area. And one of the ways you can do that is you can draw the net of the shape, yeah, to find the surface area. So there's a net of a triangular prism. And I'm going to give you this. You don't have to cut them out, but I'm going to give you this document. It should be in OneNote already. There is one little mistake on it, I think, but we'll see if you can find the mistake. Otherwise, I'll put it in the chat right now. And I'm going to put you in breakout rooms. I want you to find the surface area of this shape by using the strategies that you just talked about. These are all triangular prisms. So you should be able to find the area of each face and sum them, okay? There is one small mistake, and I'll tell you the small mistake is on the one on the, let me see if I can see my screen. It's the one that's on the bottom left of that first page. And so let's see if you find that mistake. So I'm going to give you a few minutes to go through and work on that, okay? So if you have it electronically, it might be easier if you, just to at least look at it on the screen, and then you can just do it on your paper. You don't have to draw all the little tiny squares, but you can do all the faces if you want. Okay. Okay. I'm going to put you in breakout rooms. Hopefully without me in a room. Oh, sorry. Sorry, almost there. Okay, and then I'll come visit you if you need help. Karina, are you here? You made it back. Now, you might not have been done with the whole thing yet, but you at least got done with the first page, I hope. Okay, so, and some people found the error. Let's see if yours looks similar to mine. Not what I want to do. Sorry. All right, so for the top left, did you get 204 square units? How many of you put units on there? Raise your hand if you put units on there. You win the prize. Yeah. Make sure you put units on there. You don't make up what the units are. Don't put like, oh, I think they're inches, or I think they're feet, or I think they're centimeters. Just label it units squared or square units, either way. So any questions on the one I did pink, which is in the top left? Everybody get the same thing? Nice. How about this one over here? Did you get 240 square units for the one I did in green? Any questions on that one?
I got 245. But I
Okay,
could be I could have calculated something.
so which one of your shapes doesn't match mine? You know, did you
The
write
bottom
them?
one.
What
Nope,
did you
I see
put
my-
for
I
that
see
one?
my mistake. I see my mistake.
Okay.
Yeah.
All right. Any other questions on that one, on the green one? Okay, how about the one I did blue, 48 square units?
Why would the triangles be 6?
So why would the triangles be 6? I'm going to erase right here so you can see. So remember the formula for the area of a triangle is 1/2 base times height, right? So the base of this triangle is 3 units. The height of this triangle is 4 units. So 4 times 3 is 12. Half of 12 is 6.
Oh, I see what I did.
What were you doing, Karina?
I did 12 because I think I was just stuck with the rectangles and I got in the flow of that. And then I forgot about the formula for triangles.
Yeah, very common. Good catch. Okay, and then this one down here. Did anyone notice the problem? If you didn't notice the problem, you just did it and you got 375 square units, right? Which is fine. So someone explain to me what the problem is. What's the issue here?
It wouldn't, I mean, wouldn't it overlap because the one of them is 9 by 9, the other square is well, it's not even a square, it's a rectangle now, but it wouldn't close up into a prism. I mean, not a pyramid. Is it a pyramid?
Okay. You tell me, what is it?
I thought it was a. Will they all come up to 1 point? Oh no! Sorry, it is a prism. But yeah, I would overlap because I don't know. It's just not the same size though on the sides.
So you've said two different things. In one hand you said it would overlap, in the other hand you said it wouldn't close. Which is it? And not just Madison, somebody else can help her out.
Well, once we would enclose it, the side that has 90 units, it would go up higher than the side with 81. So I think she's saying like the 81 wouldn't close because it wouldn't fit the 90.
Nice. So hopefully when we close this piece right here and this piece there line up perfectly. But on this side, since it's shorter, it's not going to reach all the way up there. There's going to be a little gap right there, right? On the top of the prism. So it would be like a slot for you to put money in for me, right? It'd be like your Valentine mailbox at school. Yeah. Remember making Valentine boxes at school? Does anyone remember that? Yeah. And so there was always a little slot for you to put stuff in. So yeah, if you corrected it, you should have gotten 384 square units. Yeah. Yeah, Brianna, you're perfect. Yeah, and Betty, that's exactly what I did. The first time I did it, I was like, oh, for sure that other side matches. So I'm not even going to do it. So for all of these, I would just calculate one side and then I just write it in the other side. Did anyone do that? Yeah, like your triangles, you knew your triangles were identical, so you were good. You knew these rectangles were identical, so you did. And that, so you only had to calculate one of them. And so Betty said she just assumed that side was 90. Me too. First time I did it. So yeah. So questions on surface areas of, these are all triangular prisms. Everybody okay?
I do have one question.
Yeah.
So like the one we did above, is it okay that that's 15 units and that's 12 units? Because like that kind of, I don't know, why is it okay there but not the bottom one?
Tell me what you think about that. Help Madison out here. What do you think?
Is it because the top piece, like the rectangle, is on the diagonal of the triangles and the bottom one is on the height?
Yeah, so if you look right here, this height is 4 and this height is 4. And so those are going to fold up exactly. But this diagonal is longer, right? This diagonal is longer than 4 because it's the hypotenuse of a triangle. That brings up the Pythagorean theorem. Okay. So then it should fit, because notice that this triangle, this is a great review right here. This is a 3, 4, 5 triangle, 3, 4, 5 triangle. So this is 5 units and this is 5 units, right? Let's go back and check this one and make sure. But see this one, these two are exactly the same. So that's why this one is different, right? Does that help? Madison, that is a great question. I'm so happy you brought that up. Did you guys see the Pythagorean theorem homework yet? Did anyone look at that yet? When you get there, there's a great activity that we would normally do in class that we can't do. It's with starbursts and making the Pythagorean theorem with starbursts. So watch that video. I'm sure it's still in that homework. Great question, Madison. Okay. So let's go back to our slides. Anyone have questions on finding the surface area if you're given a net?
I actually have one more question about what we were doing.
Yeah.
So like on an exam, if we were answering a question like this and we labeled it like area equals 204 square units, would we get points off for not saying surface area? Like, is that something
Nope.
totally separate?
Nope, you'd be fine. So
Okay.
you would be fine, because if you're finding the area of that whole shape, I would assume it's the surface area. If you want right surface area, that's fine too.
Okay.
Good question. Okay, name this figure. Just say it out loud.
Pyramid.
What kind of pyramid?
Square
Square.
pyramid.
Very nice. Square pyramid. Name this one.
Triangular
Triangle
pyramid.
pyramid.
Yeah, triangular pyramid or a tetrahedron, right? Okay. So triangular prisms we talked about. How would you find the surface area of this and what shape is this?
Rectangle prism.
Yeah, a rectangular prism. How would you find the area of this? It's not a trick question.
You could take the area of each rectangle and then add them all together.
Yeah, do what we just did, right? Now, the only thing that's nice about a rectangular prism is I have lots of sides that are the same, right? These two match, then these two match, then these two match, right? So it might be a little bit easier, you know, than on a triangular prism. So, and this is the second page in your, on that sheet that we were just doing. So you could find that. This is a great activity too. Draw the net and then compute the surface area. Okay, so that's the next page on there. But let's talk about formulas. Some of you have seen this formula for a rectangular prism. Does this look familiar to anyone? 2LW plus 2WH plus 2LH. Has anyone seen that formula before? Nobody has, only me. Okay, Kelsey says she has. Now, that refers to this rectangular prism, right? So we could do, we have two of these, two of these, two of these. That's what it's doing. It's just adding them all together, right? I never used a surface area formula on prisms because I could just dissect it. If I had the net, I could find the surface area, right? So I didn't need the formula. This is the formula that textbooks for adults give, just so you know. Most of the time in elementary schools, they stay away from formulas for surface area. They just let kids dissect them with these nets. But this formula right here, look at this formula. 2 times capital B, where B is the area of the base, plus the perimeter times the height. Think about that formula. So the area of the base, and then we're multiplying it by 2. Why would we multiply it by 2?
Because with prisms, there's usually two bases for everything but a triangular prism.
Wait, there's usually 2 bases, or are there always 2 bases?
Usually, I said for everything but maybe a triangular prism.
Anyone agree or disagree with Elena? No one. There are always 2 bases in a prism. Always. In every type of prism, there are 2 bases. That's the definition of a prism. They have 2 parallel identical bases. When we get to a pyramid, we only have 1 base. But in all prisms, we have 2 identical parallel bases. That's where this 2B comes from, right here. Now let's talk about this other crazy part. What's this talking about? The perimeter times the height. What is that for? Any ideas? Let's go back to our shapes and think about it. Let's go back to this. Okay, any of these. We'll just take this one. So if we were going to find the surface area of this, these are the bases, yes? So that's our 2B, right? Find the area of a base, double it. We good so far? Okay, now let's talk about this part, this pH. P is the perimeter of the base. So now they're saying take this distance around the outside of this and multiply it by the height of the prism, which is that. Does it work? Yeah, it does work. But why? Can you figure it out? Let's think about what we did. When we did ours, we said, I don't even remember what these measurements were, but you guys can fill them in for me. I can pull up my other document. I just wanted to stay on here for a second. So if we do 2 times the area of this, which the area of that was 12. So we're going to do 2 times 12 for this shape. And this perimeter, we would have to do a little bit of work. This is 8. This is 3. Does anyone know how I would find the length of these sides? You can say no if you don't know. Okay, so this turns out to be, I'm going to erase some of this so you can see it. If I draw that height in there, we know that's 3, yeah? If that 3 bisects that line, then each one of these are 4, yeah? How can I find the length of this side? Is that a right triangle now? Can I use the Pythagorean theorem now? Yeah, I can. So remember, the Pythagorean theorem is a squared plus b squared equals c squared, where a and b are legs. So 3 squared plus 4 squared equals c squared. So 9 plus 16 equals c squared. So 25 equals c squared. So c must be 5. Yeah, that was fast. But you've done that a million times before, the Pythagorean theorem. So these are 5s. So now what it's saying is if I'm going to do this part of the formula, this pH, I'm going to take the perimeter, which is 8 plus 5 plus 5, so that's 18, times the height of this prism, which the height of this prism is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. So if I do that, I get 24 plus 180. I get 204, which is what we got already with dissecting the shape. So what doing this perimeter times the height is it's finding all of these. That's what it's doing. It's finding each one of those rectangles. It's just doing it in one step. Yeah? Because it's saying, okay, 5 times 18, and then 8 times 18. I'm sorry, I don't remember. Was this 18? Yeah. And then 5 times 18 again, which is exactly what we did already. So, but would you have ever thought of that formula? I wouldn't have. I think it's easier just to dissect this. And that's how it is for an elementary school student. It's easier to just dissect it instead of make up this formula. But that formula works, by the way. In case you need it, that formula does work. And that formula I'm going to provide with you. So if you look right here, that's what we were talking about right here, this prism, 2b plus pH, and I give you all of these definitions. Now, a pyramid's different. A pyramid's formula is this. Notice that L is the slant height. Sometimes it'll be given to you. Sometimes you'll have to find it using the Pythagorean theorem. Okay? Now, let's look at this formula here. A cylinder. A cylinder looks like this, yes, vaguely, especially when you draw it correctly. Cylinder looks like that, right? If I draw the net of a cylinder, what does it look like? It has 2 circles, do you agree? 2 circles. And then what does this part look like when I unroll it? What shape would it be?
A rectangle.
Yeah, nice. Okay, it's a rectangle. Now, I want you to think this through. What's the formula for the area of a circle?
Pi times radius squared.
Nice, pi r squared. And then how many circles do I have in this picture?
2.
2.
Thank goodness, man, sometimes I'm worried. Okay, so that's where this comes from. 2 pi r squared, that's this, right? You good so far? Makes sense? Now, let's think about this rectangle. When I unroll this rectangle, it looks like this. Now, notice my height is still my height, right? That didn't change. So that's where this part comes from. Where did this come from? 2 pi r.
It's because the other edge of the rectangle is the circumference of the circle. And so circumference is 2 pi r or pi d.
Nice! That's exactly what it is. So all this formula is dissecting this shape into 2 circles and a rectangle. So that formula makes sense. 2 pi r squared plus 2 pi r h. This one's a little bit harder to follow. I think you can see the pi r squared. That's the bottom of the cone, right? This part's a little harder to see. Pi r times L. It's when you unroll this, it's a very strange shape, right? When you unroll it. So the derivation of that is a little bit harder. Okay. But these formulas will be provided for you. Okay, so if I ask you to do surface area of any of these shapes, you can use these. Now, you don't have to, right? On some of them, like if I give you a net, you don't have to, but you can. All right, deep breaths. Everybody stretch. That was a lot. It was a lot of info. I have good news and bad news. Which do you want first? You're like, I don't want either of them. They're both bad. Oh, okay. Brianna wants the bad news first. Here's the bad news. We have 7 minutes left, and I have all that stuff. Yeah. So that's not going to happen. We know that, right? Here's the good news. Class is over in 7 minutes either way. Okay. So here's the bottom line. Volume is fascinating. I'm telling you, it's fascinating. And I have some videos that I can put up about volume, but I'm going to show you just this little bit so you can see it. And then you have the formulas for volume, but I'm going to show you something because this is a life changer for people to understand. Okay. Are you ready for our life changer? Do you see this shape? I know it's clear. Can you see it? It's a cube. Everybody okay? This is a cube. This is a square pyramid. See it? Okay. A great activity that I do in class with my students. Do you see that these two have the exact same base? Like these two match. They're the same area. So these two areas are exactly the same. Okay. Now the other thing you might not be able to see, especially because I don't have a table right here. These two have the exact same height. They really do. They have the exact same height. If I put a piece of paper on the top, which I can, hold on. Let me do it so you can see it. If I put a piece of paper on the top of these or a whiteboard on the top of these, I'll hold it up. I'll move it. So here, hold on. Let me show you. Do you see? They have the same height. This isn't slanted at all. I know my hand is, but this is the exact same height. Like this is flat. So the only difference between these two shapes is how much they hold, okay, which would be the volume of these things. Other than that, the area of the bases are identical, okay, and the heights are identical. So I'm going to ask you a quick question. This has got to be real fast. How many of these pyramids, how many of these do you think it would take to fill this up? If I was going to fill it up with water or sand or rice or something, how many pyramids would I need to fill up this whole cube? Okay. How many of the pyramids would it take to fill up a cube? Think about it for about 10 seconds. Put your answer in the chat. Okay, 3, 2, 1, go. Think about it. I see a lot of 2s. You want to hear the crazy thing? It's 3. Yeah, it's 3 of them. It's true. It's the craziest thing. It's 3 of them. Now, when we look at the formulas of these two, the formulas are identical, except this formula has a 1/3 in front of it. Yeah, so the formulas are exactly the same, except it takes 3 of these to fill up one of these. By the way, I have a video that shows this. It's a great video. Okay, the other one, this is a cylinder, yeah? Cone, yeah? Same thing. They have the exact same bottom. I promise you they're their exact same height because that's how they're made. How many cones would it take to fill up a cylinder? Anyone know? How many cones to fill up a cylinder? You can put it in the chat. 3, 2, 1, just guess. Go. Sorry, I'm trying to put something in our thing too. It's 3 again. Is that crazy? It's 3 again. Okay, I know you don't believe me. It's true. It's crazy. This is a whole experiment. So I'm going to show you. I just put the formula sheet here. Look at the formula for, remember we just talked about a prism versus a pyramid. Look, the only difference is that 1/3. A cylinder versus a cone, the only difference is that 1/3. Crazy? Yeah, it's weird. This is a great fun experiment that's really great live, but at least I'll send you the videos so you can see it. And there's also in one of the videos, it talks about a sphere too, and how we can derive the formula for a sphere. Now I'm going to look at our exit ticket because I can't remember if I covered what is on your exit ticket. Let's take a look. Oh, and then these are all just examples. So if you want to see some examples of computation, look at the slides. You know, don't cheat yourself. Try to compute the surface area. Like this is compute the surface area. Then there's the answer. Then this is compute the surface area. Then the answer. Compute the volume, the answer. Compute the volume, the answer. Okay. So let me look at your exit ticket. I'll put it in the chat for you. Hopefully we can do it. I think we might as well at least try, right? And otherwise, have a great day. Oh yeah, that's a net, that's surface area, and that's volume. I think you can do it now that you can see my formulas, and I'll put the formula in the chat too. I mean the formula sheet. Just try it. If you get it wrong, it's fine. All right, great job today. I will see you tomorrow. One more day. One more day. You can do it. Hang in there. I'm sticking.